Good afternoon, dear colleagues. I present a report on the topic Management of Unmanned Aerial Vehicles SWAM, an overview. Unmanned aerial vehicles play a key role in the future, providing support for various services for humanity. Although UAVs play a major role in defense and military purposes. Also, UAVs helps in a wide range of scientific and applied problems. One of the most popular uses of UAVs today is to use them in swarms, groups. The main difference between the formation lie in the UAV control system, principles of organization and interaction within the group itself. Swarm. This is one of the most complex formations, where each UAV operates autonomously, following simple rules of interaction with neighbor UAVs. There is no fixed leader in the swarm, and each UAV uses information about the location of neighbor UAVs to coordinate its actions. The main characteristics of such a formation are its use of decentralized control. Each UAV receives data from its neighbors and not from a single control center. The possibility of scalability of the formation, adding or removing UAVs, does not disrupt the structure and stability of the swarm. Self-organization. The swarm can adapt to changes in the environment or task without external commands. Hive. It's a formation in which UAVs closely interact and perform tasks as a single unit, often using a single algorithm or a given route. Unlike a swarm, a hive can be more organized and have a specific structure or main goals that they achieve collectively. Unlike a swarm, in a hive, coordination is carried out around a common algorithm, while the hive can form different structures, while maintaining a common goal. It should also be noted that a hive is more resilient to the loss of even a large number of UAVs. This approach is characterized by the use of centralized control, but the sets of sensors will be similar to the sets of swarm. The difference will be that the hive must use machine learning to improve natural coordination and adaptation to different environments, and the communication equipment must be designed for data exchange between UAVs and a centralized hub. Cluster. Cluster is a formation in which several UAVs are united to perform a common task, but each UAV can perform a unique role. A cluster often has a leader or central UAV that coordinates the actions of the others. This type of interaction is implemented through the use of centralized or semi-centralized control to increase efficiency. Each UAV can do its part of the work depending on its purpose. Network formation. It implies that UAVs are united in a network, where each UAV can transmit information to another, as well as process and retransmit data. This formation is characterized by the use of continuous data exchange. When using this formation, constant synchronization and rechecking of each UAV for validity is necessary. In case of failure, the road is built using another UAV. This approach is best used to organize communication other large areas. Formation flight. A column is a more organized formation in which UAVs follow a clear sequence or form a predetermined geometric shape. This formation is characterized by UAVs following a given road in a certain sequence, with each UAV having its own fixed place in the formation. The distance between UAVs in the column is equal and constant. To maintain the shape, the leader-follower algorithm is mainly used to follow the leader. UAV application tactics. Most popular tactics is mass. Several UAVs are combined into groups to perform a task. Joint bulk of UAVs according to a single algorithm. They act synchronously following certain routes, which gives them numerical superiority and allows them to achieve greater results. For example, during observation or synchronous action. Here, each UAV, although autonomous, still works as a team, which allows it to remain effective when performing clash. Next tactics is meal. These tactics like swarm. Each UAV acts according to its own rules, but within the framework of a common strategy. Although the UAVs do not follow a single leader, they still interact and perform a common task, which allows for a certain level of organization in the chaotic coordination of the mission. Network formation or maneuvering. In this formation, UAVs can coordinate its actions by transmitting data to each other and adapting roles in the real time, which allows for saturating the required areas. This allows for maneuvers such as flanking an enemy. In this formation, UAVs can be divided into groups that perform different tasks but constantly interact and adjust their actions to achieve a common goal. Segmented teams. Dividing the swarm into groups that perform different tasks. One group can scan and another deliver equipment. They can the key here is the constant exchange of information between subgroups, which ensures coordination and efficiency in the execution of complex missions. This organization allows for several tasks to be performed simultaneously, providing a high flexibility in mission execution. For release these types of tactics, we can use next methods. First, it's a Markov Decision Process. In this method, the world is divided into states, and each state represents a possible configuration of the environment. A state is a position in space, a completed functional task, an opportunity to use an available tool, etc. In each situation, the agent has several options for behavior. Each action changes the environment and causes a transition from one state to another. In Q-learning method is that allows an agent to determine the optimal strategy by calculating and sorting values for each state. The value of each state is calculated based on the reward function and the transition function, and all states must be known. In the case where the functions are unknown, the agent learns experimentally. After conducting experiments, the agent chooses actions that lead to states with the highest value until it reaches the goal of rewarding state. In policy gradient algorithms, the policy is a mapping between a set of states S and parameters theta and the probability that the agent will perform action A. Based on the above and the counted variants of tactics use of a UAV swarm, we can distinguish 6 of the most common tactics. A flock act implies the movement of the swarm to the target regardless of any obstacles. When using the flock tactic with the choice of the closest, each UAV chooses as a task the one that is closer to its location, and the criteria of the basis of which the UAV from the swarm chooses these tasks are usually specific. The following can be used as such criteria. The distance to the target is less than 20 meters. The distance between the center of the swarm and the closest target is less than the distance between the obstacles and closest target, and etc. The tactic of choosing the closest is the choice of the closest target. Rabbit tactics involve using a single UAV as a distraction. Swarm tactics involve dividing the swarm into groups or clusters to perform tasks. Cycle tactics involve attempting to encircle a necessary area to effectively complete a task. So then, modeling mission is particular territory. The area of the territory to be considered for the selected period of time was chosen as a parameter of monitoring officially. For this purpose, the simulation model realizes the function of coloring the territory located in the ellipsoid of the local neighborhood for the observed UAVs. After the end of the monitoring time set by the user before the experiment, the area of the colored territory is calculated. For modeling the movement towards a given object, it was found that the greatest effect is expected when using UAVs in the form of self-organizing groups, flocks, swarms, clusters, orders, etc. With a variable degree of autonomy in time and by a control function from remote control to fully automated behavior. For modeling the movement of UAV swarm, several UAV models were placed on the stage and its original positions were adjusted. After adding the ROS interaction script and the control program modeling subscripts, the UAV team behavior simulated was launched. Thank you for your attention. Goodbye.